Hey guys, I wanted to read you a story about fractions today to help you with your fraction worksheet. We have talked a little bit about fractions and we're only focusing for the most part on halves and quarters, but I want to talk about what the numbers are in the fractions. The top number is called the numerator and the bottom number is called the denominator. The numerator is how many pieces of the whole and the denominator is how many pieces in all. So here's a story called Working with Fractions by David A. Adler, illustrated by Edward Miller. A fraction is a part of something. You see fractions at birthday parties. If there are 3 red balloons at the party and 10 balloons in all, then a fraction of the balloons is red. 3/10 of the balloons are red. If you play musical chairs at the party and 5 of the 7 children are sitting on chairs, a fraction of the children is sitting. 5/7 of the children are sitting on the chairs. If a pizza is served at the party and the pie is cut into 8 equal slices, then each slice is a part, a fraction of the pie. Each slice is 1/8 of the pie. If the birthday cake is cut into 12 equal slices, then each slice is a part, a fraction of the cake. Each slice is 1/12 of the cake. Fractions are not only found at birthday parties, fractions are also found everywhere. Think of how you use fractions every day. Each time you read a page in a book, you are reading just a part or a fraction of the book. If the book is 96 pages, each page is 1/96th of the book. Coins are fractions too. There are 20 nickels in a dollar. Each nickel is a part, or a fraction of a dollar. Each nickel is one of 20 nickels in a dollar. Each nickel is 1/20th of a dollar. Now you know some fractions. You know 3/10, 5/7, 1/8, 1/12, 1/96th, and 1/20th. Take a look at 3/10, the fraction of balloons that are red. The 3 tells you that there are 3 red balloons. The 10 tells you that there are 10 balloons in all. Take a look at 5/7, the musical chairs fraction. The 5 tells you we were talking about 5 children, the 5 who were sitting. The 7 tells you that there are 7 children in all. Take a look at 1/8, the pizza slice fraction. The 1 tells you that we are talking about 1 slice of pizza. The 8 tells you that we are talking about 8 slices in all. Each fraction has a top number and a bottom number. The top number of a fraction is the numerator. The bottom number is the denominator. In the fraction 3/10, the numerator is 3 and the denominator is 10. In the fraction 5/7, the numerator is 5 and the denominator is 7. What happens when the numerator or the denominator changes? What if 5 of the balloons at the party are red, then 5/10 of the balloons are red? 5 is more than 3. 5/10 is more than 3/10 of the balloon. What if 6 of the children in the game of the musical chairs are sitting? Then it's 6/7 of the children that are sitting. 6 is more than 5, so 6/7 is more than 5/7. What if you ate 2 slices of pizza? If you did, you ate 2/8 of pizza pie. 2 slices we know is more than 1 slice, so 2/8 is more than 1/8 of the pizza. The larger the top number of a fraction, the larger the numerator, and the larger the fraction. When the denominator, let me say that again. The larger the top number of a fraction, the larger the numerator, the larger the fraction when the denominators or the bottom numbers are the same. And that is because the number of pieces doesn't change. You just are eating more of them, or the number that it occurs is larger. So the top number, the numerator is going to change, but the denominator is going to stay the same if you're talking about the same objects. At the birthday party, what if the pizza pie was not cut into 8 equal-sized slices? What if it was cut into 10 equal-sized slices? Because more slices were cut from the pie, each slice would be smaller. Each slice would be 1/10 of the pie. The fraction 1/10 is smaller than 1/8 of the same pizza. So the pizza is the same, but look at the sizes of the slices. Because you want to now cut it into 10 slices down here, you now have to cut them smaller. So the 1/10 is going to be smaller than 1/8. You see the slices are different sizes there. At the birthday party, what if the cake was not cut into 12 equal slices? What if it was cut into 15 equal sized slices? Because more slices were cut from the same cake, each slice would be smaller. So it's the same thing like the pizza. Each slice would be 1/15 of the cake. The fraction 1/15 is smaller than 1/12 of the same thing. The larger the bottom number of a fraction, the larger the denominator. The smaller the fraction when the numerators, the top numbers, are the same. Now, this is way more advanced than what we're working on for fractions, but it's just to give you an idea and understand fractions a little bit better. And you'll get into more detail about this next year and in 3rd grade and 4th grade and so on. But like I said, this was a fun and exciting book to me, and I wanted to share it with you to help you understand fractions a little bit better. Folded sheets of paper and crayons can teach you about the numerators and denominators. Here's a sheet of paper that has been carefully folded twice, then unfolded. The creases divide the paper into 4 equal sections, or quarters. Each section is 1/4 of the paper. So this is what kind of fractions we have been learning about. Fourths and quarters. Take a sheet of paper and fold it so the creases divide it into 4 equal sections. Shade 3 sections of the paper red. Shade the remaining section blue. Take a look at the red and blue sections. The red part, 3/4 of the paper, is larger than the blue part, 1/4 of the paper. 3/4 is more than 1/4 of the same thing. The larger the top number of a fraction, the larger the numerator. The larger the fraction when the denominators, the bottom numbers, are the same. So this is just a way to help you understand what fractions look like. And when you're comparing the fractions, that even though the numbers, it's pretty obvious that the number on top is bigger. So you would obviously have a bigger fraction. And you can do this to practice if you would like, but I'm not requiring you to do it. Take another sheet of paper of the same size paper and carefully fold it in half. Then unfold it. There's a crease in the middle of the paper. The crease divides the paper into 2 equal sections. Each section is 1/2 of the paper. Now, shade one section, or half of it, the paper, into green. Next, look at the 2 papers. Pay attention to the blue and green sections. The blue section, 1/4 of the first sheet of paper, is smaller than the green section, 1/2 of the second sheet of paper. 1/4 is less than 1/2 of the same thing. The larger the bottom number of the fraction, the larger the denominator, the smaller the fraction, when the numerator and the top numbers are the same. And that is because even though this number on the bottom is bigger, you have to divide that shape up into more pieces. So this, as we saw with the pizza and the cake, the slices or the pieces are going to be smaller in order to fit them all. So that would mean that this would be a smaller fraction than this. And you can see that when you put them next to each other. This piece is obviously a lot smaller than that. You can play tricks with fractions. If a birthday cake is cut into equal-sized slices, each slice is the same, but 1/12 of one birthday cake might be more than 1/12 of another cake. 1/12 of a larger birthday cake is more than 1/12 of a small cake. So just because the numbers are the same, the size of the original, the whole thing, is different. So the sizes of the pieces are going to be different. 1/12 is more than 1/15 of the same cake, but 1/12 of one birthday cake might be less than 1/15 of another cake. 1/12 of a small cake might be less than 1/15 of a bigger cake. Sometimes the same fraction has different names. Take 2 white paper plates. Let's pretend each plate is a birthday cake. Before you cut the cake, you decide to serve 1/2 of it at the party and save 1/2 of the cake for later. With a ruler and a pencil, draw lines to divide each plate in half. With a crayon, shade the half of each plate. That's the half you will save for later. On plate 1, divide it again until you have 12 equal pieces. Take a look at the second plate. What was once 1/2 is now 6/12. 1/12 and 6/12 are really different names for the same fraction. It would be the same if you saved 1/2 of the cake for later or ate 6/12 of it. Again, this is a much, much more complicated task than what we are supposed to do. So it just keeps getting more complicated. So I'm going to skip some of these pages because they don't deal with what we are working on and I don't want to confuse you. So let's see. I'm going to skip to the last page. Fractions are at birthday parties. Fractions are at football games. Fractions are in shoe stores. Fractions are in clothing stores. People use fractions to tell time. People often use fractions. Fractions are everywhere. 1/4 of the football game is 15 minutes long. Coats are on sale. The clown's shoes are size 12.5. The time is 1/4 past 6 o'clock. So 1/4 past 6 o'clock. So when we use the clock, we will learn more that when the minute hand is on the 6, it means that it's half past the hour. It's 30 minutes past. And that is because each number you count by 5s for the minutes. So when the minute hand is pointing to the 3, the minute would be 15. And 15 is 1/4 of the hour. If we split the clock into fourths, just like this, the 3 is where it would be split as the line for one of the 4 sections. So hopefully this helped you out a little bit with understanding fractions. Again, I want to go over and review that the denominator is the entire number of pieces, all of them, and the numerator is the number of pieces that you are working with at that moment. So the numerator will always be smaller than the denominator.